Okay, you guys, talked a little bit. Tell me anything you know about any of these triangles. Which one do you want to start with? Okay, equal. A very big deal in this one. What do we know about equilateral triangle? Say it one more time. We both start. Yep, how many sides are in a triangle? Okay, so 3 sides are congruent. What about its angles? Yep, so 3 angles are congruent. What about an isosceles? Do you want me to sketch one too? Yeah, okay. I'm gonna do a rough sketch. So this is an equilateral triangle. These are all congruent, and these are congruent. Do you know what all these angle measures are? Yep, so all 60 degrees. Okay, draw an isosceles triangle. I'm gonna draw it like this. What do we know about it? Vincent, what do you know? You said it earlier. You guys were talking about it. Yeah, so 2 sides are congruent. So how many angles are congruent? 2. Yep, 2 angles congruent. So it's this side with this side, this angle with this angle. So like a 45, 45, 90 in the past was one of our right isosceles triangles. Now scalene. Have we seen the word scalene before? Yeah? What do we remember about a scalene triangle? I'm gonna draw a little sketch. I'm gonna call this a scalene triangle. Yep, okay. So all different sides. So the angles have to be what? Yep, all different. So if 3 congruent sides, 3 angles are congruent. So that pattern keeps continuing. Now a right angle doesn't really go by this pattern. I'm gonna draw a right angle triangle. A little shaky. Oh, I already do it. What do you know about a right angle triangle? What does it always have? Yep, a 90-degree angle. That's opposite what side? The hypotenuse. Yep. And it must satisfy what formula? Or what theorem? Yes. Must satisfy a squared plus b squared equals c squared. That bit is going to be very important to us. So today's lesson is really just a review of stuff we've done in the past. So in the past, we were talking about shapes on a coordinate plane, right? You guys were talking about that when we're talking about like parallelograms. If this was the coordinates, is this a square? Is this a rectangle? Is this a rhombus? That kind of stuff. So we're gonna pretty much be talking about the same thing today. This unit is really, or this chapter, at least not the whole chapter, just this lesson, is really just review. But this is called a polygons in the coordinate plane. What is the coordinate plane? Can you all get up and move around the room and find me a coordinate plane? Up, up, up. The guitar? Okay. Yes. Yeah. So that's a coordinate plane. We are doing coordinates on a plane. So plane is a surface. Lily did it so fast. She found it. So we're talking pretty much about a graph. Yes. So I'm gonna give you a problem and we're gonna talk about it for a little bit. Drew, I'm gonna have to go back in 1 second just because I have to copy and paste something. But then I promise I'll go back. So, no. This is my coordinate plane. This is my triangle. I would definitely recommend that you sketch it and label it as I have it here in your notes, which I'll get to in a second. Do you guys want little graph paper? Okay. Paste this. Good, Drew, with the notes? Okay. Okay, I'm gonna scooch down. This is my triangle. I'm gonna make the points a little bit more bolder here. Oops. So A is right here. A is 1,6. What do you call these, what I'm writing right now? B equals 3, 1. What do you call that? Ordered what? Ordered pair, yes. These are my ordered pairs of my points. So those are all 3 points. Go ahead, sketch it. I'll give you a minute. Okay, I don't know. Yeah. Oh, I'm sorry. I think that's because. Okay, if I asked you to find the length of AB, what would help us find the length of AB? What formula from the past that helps us find the length of the side? Or just the length of a line? I want to get from one point to the other. Who remembers a formula we had to use? We got like chapter 4. Okay. I don't know, what's the chapter? Okay, what do I change this? Find the distance from A to B. What formula am I using? Distance formula. Who remembers the distance formula? Nobody. Okay. D. I'm gonna do small d. I'm gonna square these and add them together. Who remembers my distance formula? What am I putting in the parentheses? What's my first point? Yep, A. So I have my x and y values from A, and I subtract them my x and y values of B. So that is my second point. I want you guys to find the distance from A to B.
Oh, today? Yeah. Okay. I like this. I need to keep that.
Who remembers using the distance formula? Thumbs up? You do, thumbs down, you don't. Everyone needs to speak. Thumbs up or thumbs down? Okay. Camille, what did you start with? Yeah, what do we substitute? Squared plus what? 1 minus 6, yep. Is that what everyone else got? Yep. Alright, this was the first point. This was the second point. And we'll say this is the third point. A, B, C, alphabetical order. So, AB equals, we have 2 squared plus negative 5 squared. So that's 4 plus 25 equals square root of 29. Thank you. So that's our first equation of the day, distance. Now, what if I asked you, what is the slope of AB? What formula do we have to use then? Yep, rise over 1. So slope indicated as little m equals what? What is my slope formula? Ashley, do you remember your slope formula? Yep. Can you give me it as like coordinates? Because we're in the coordinate plane. So I'll put rise over 1 equals, rise is x or y? Y. Yep. So we have y2 minus y1, and run is x or y? X. So we have x2 minus x1. Find the slope of AB. Ashley, what did you get for the slope formula? What did you get as your answer for AB? Okay. 5 over 2? Can we also find the slope of BC? Okay. Drew, this is going to you. We all get the same slope for AB. Finish slope of BC. We're going to go back to that. Okay, Carson, Drew, either one of you, since you guys are partners and you guys definitely will talk to each other, right? Do this? Yeah? Okay. What should I put in my numerator? Yep. What about my denominator? Yeah? What do we get? 2 over 5. Now it's positive, right? Yep. So going in a positive direction. Let's go back to this slope. I got 5 over 2. Did anyone else get 5 over 2? Thumbs up if you did, thumbs down if you did. Okay. If I go from A to B, am I going in a positive or a negative direction? Positive or negative? Negative. I should have a negative slope. So let's go through this one time. Let's do this. So B is my second one. So I have 1 over 3 minus, I'm scooching up because I can't see it, 6 over 1. So I should get negative 5 divided by 2. Questions that we got? That's okay. Did you do 6 minus 1 and 1 minus 3? Okay, as long as you keep it consistent on what your first value is and your second value is, like what coordinates first and second, that's okay. These slopes, they look pretty similar. What do we call them? If we're flipping them and then negating them. Not exactly. So reciprocals, yes. And we have a negative. So negative reciprocal. Definitely put this in your notes with slope. So slope, oh, formula was little m equals y2 minus y1 over x2 minus x1. So if negative reciprocal slopes so you see something like m2 equals negative 1 over m1. What does that tell us? It forms something. What does that tell us? This is review. You guys already know this. If it's a negative reciprocal slope, these two lines are perpendicular to each other. So they form what type of angle? A right angle. Then lines are perpendicular and form right angle. What if they were the same slope? same slope. So M2 equals M1. Then we have parallel lines. Perpendicular. Right here? Reciprocal? Yeah. Reciprocal, negative reciprocal slopes. Yep. Then our lines are perpendicular, and we get a right angle. Camille, where did I form my right angle in my picture? Where is it? B. Yeah, perfect. So B is right there. I will scooch down so you can write it. Guys, those were the two easy ones. Okay? We got one more we gotta do. This one's the hard one. I'm gonna ask you to find what point bisects AB. Vincent, do you remember what the word bisect means? Why bisect something? Why bisect? What do you want to bisect? Give me any shape you want. Triangle. Okay. I'm gonna bisect this triangle. Bi means what? Two. So I'm gonna cut it right in half and make two equal triangles. Boom, boom, boom. If I want to bisect AB, I'm scooching it up. I'm trying to find what of this line? Yep, the midpoint. So let's say like right there. Something like that. I want to find the point that's in the middle that makes two congruent segments of this line. So makes two congruent segments. And Lily, what did you call it? That point that I drew? Midpoint. So we are trying to find midpoint. So this is the midpoint formula, which we denote as big M. Have you guys seen midpoint formula before? Yeah? Yeah? Right. So that's x2 plus x1, doesn't matter which one goes first, divided by 2, comma, y2 plus y1 divided by 2. Now I wrote this as a what? As an ordered pair. This is an ordered pair. So I'm going to draw this. This is my midpoint formula. Okay, can you guys find me my midpoint? Okay, what do I get for my midpoint, Carson? 2.5. Let's check it. Let's move up. So you said -1, 2.5. That's right there. That's not my line. So let's go down. Let's put in these points. Did you add or subtract them up top? Okay, I think that was the thing. So we have 1 plus 3 over 2 What are my y coordinates? 6 plus 1 over 2. So that simplifies down to 4 over 2, which is 2. And this is 7 over 2. 7 over 2. So that should have been my midpoint. Let's check it. What is 7 divided by 2 as a decimal? Yep. So I go 2 up 3.5. So that's exactly where that point was. Great, you found the midpoint. And then Lily was so nice and was going to find us the distance of BC. Did you find it, Lily? Yeah. What was it? Oh, of 20 what? 29. So if this is square root of 29, and this is the square root of 29, and I have a right angle, what type of triangle is this? Isosceles and what else? Not Lily, sorry. Right. Yes, so I have a isosceles right triangle, which is also called 45, 45, 90, which we talked about a lot. Yeah? Okay. You guys are such low energy today, so I'm getting you up. Drew, what's up? Yes, I can. I'm going to give you another triangle, and you're going to have to figure out what type it is. Okay? What are my different types of triangles? Perfect. Thank you. I'm just going to count off your 1, 2, 3. 1, 2, 3. 1, 2. Got it? Yeah. Okay, go up on the boards. I will have your problem up in a second. Actually, I have them. You can just keep writing. Okay. At each board, okay, moving up. There will be graphic. A coordinate plane or two. You guys want three. Wait, want this? Do number 2. Yeah.
So basically, this is what we're in Thursday.
Yeah. Yes.
Andrew, you else?
Yeah, this is.
This board, please.
Yes. Okay, okay, we are looking at number 1 or 2. So,
So to find a single triangle, we have to run through the Polygons.
I was introducing it. I know. Now we found 2 equal sides and try to angle. So we could stop there. But I want to choose 2. So only have to choose 2. For the triangles, yeah, got that one. Yeah. Okay, we're gonna use it. Yeah.
What point
I stepped down. We did step early on in the year.
Mm-hmm.
When we did this, it was also coordinate based instead of making them use this. Like we did this formula, obviously.
Yeah.
And then they might not remember it, but just break it into components. So just do x half distance and y half distance between the two, and you can find it without like.
Yeah.
Just sorry, midpoint.
This still look great.
Rather than using the formula, like if it's just line to line, they should be able to, or at least they were at one point, be able to do it without having to use the formula.
And you.
It's yeah.
It's just cool. So these are the people. We just need a picture.
Lily's group, why don't you all pick one side, and then you guys will find the distance of your side. So I think Drew is doing AB. So Chio,
What's the? Can you grab my notebook?
BC, and Lily do AC. Yeah.
That one.
Okay.
Yes.
Usually gonna say, there you go. Just
Let's go AB.
it will, but you can use that if you want it. It's just it's a wet erase.
Oh, he went over there.
What are you finding that this is? Maybe.
Can you give me one?
So what? It's do the square root of the other side. It's just multiplying two negative numbers together. If I do negative 5 times 5. Oh,
What you said.
yeah. Okay, so that's 1.
Oh, there she is.
Hi. What side is this? AB? Okay, what's the square root of 36? 6. So I went from here, I went over 6. Perfect. Now, no, you gotta wait.
Oh,
But you could have also just gone like 1, 2, 3, 4, 5. There's a straight line.
yeah.
Yep. So, do we know what triangle it is yet? How do you know it's isosceles? You're doing the distance?
Yep.
Okay, find me the distance of the other 2 sides to prove to me that this is an isosceles. Yeah? So AC and BC. Yes. Should they be equal or different? Equal, yeah. If you rate.
When you did 9 squared, you were doing it 2 times. I think that you wrote 8 with the you can use the but that one and like everything's good, but what do you you had yeah. And then once you change that number, then I'm okay with it. So that's 9 plus 81. Good. I think you can check with Drew once you get your answer, but I like the way you set it up.
What is the area of
Square. My kid. All right. Love it. Or was this all number 1? Or which one are you working? I was working on the. So you're doing the AZ for. I just gotta find out. So let's check. We get roots and right? So, and I just looking at here and it's the problem. Let's just check. When we're doing this. So when you write the formula, I'm gonna write it here. X1 minus X2. Squared.
Okay. From A to B, how far?
Y2 minus Y1.
6. Oh, yeah. Yep.
Squared.
What did you find in the point of A? Cool. Did you
So let's
do
check.
that? I love
Let's
that.
see if we did that. What's the X1 and
Yeah.
Y1?
Well, like, I'm happy that you did that.
So do you agree that we can, sorry, it doesn't matter if this one, but I'm first.
So,
So you say 0, 0? Could you do that? 0? Okay, what about square X2 and Y2? Sorry. 0, 0 for the first one. And 6.
show me the line.
Equals square root of 90. And X8. 6 0 equals. Oh, square root of. What did you, so like, I love that I hear you say that. What did you, 3 square root.
Okay, so these are the same.
And what's going to change? One's
One's different.
36.
And
So
an
0
isosceles
minus
is 2.
equal
Okay,
equal
2
size.
equals
Negative
6.
6. And then square.
So it is.
36. It is. So let's just
But
you're cool.
no, it's not scaling because it would
But
be
just get that. What was your 6 first? You can type it here. 0 minus 6 and then square root after you type it. It is an isosceles. That rolls them. It's clearly an isosceles.
I think
Good. And hit this. It's like so that should be a button. You don't even have to do it.
How do I pronounce this?
So up to the left answer. So hit enter on that. And then just hit answer. Okay, so there's a 36. 36, and I don't think you need to use a calculator, but you're welcome. What about the other one? Good. And what's the square root of 36?
Did you figure it out?
Yep.
What number square gives us 36?
Okay, so type of triangle. So Vincent was right. And he was right.
Boom.
What is the midpoint of 8?
And then I'll just show you. Do you agree that to get from here to here, you don't
3
have to
comma.
change any in the y direction? And how many, like just by counting, how many would go from here to 6?
What is this point? If I was on,
Just
sorry, I'm going through what? If I was on my coordinate plane.
love it.
That's my
Like, I'm
coordinate
sorry, I
plane.
didn't realize that.
What is that point?
Your
right
math, like the way you set it up was good. We just had it wrong.
3, 0. Great.
Love it.
Now,
Cool.
can you guys
So what are
find
we trying to
me the perimeter of a triangle? Do you remember what the
And
perimeter
you
formula
working with
is?
them or some okay. So I'll wait for Miss Sweet. I don't know where she wants to go.
Yeah, do it. And then after that, find me the area.
So like Carl went
You're adding all this down.
I think I have the area. Science.
No, these are all the same. So we found,
Like I remember
we
it.
found
and it's-
AC,
Oh,
which
you
is 3 square root of 10, and then
P equals
3 square root of 10, and then 6. So just add all those together. Just a calculator.
Okay.
So that's for a square though.
So decisions here. Nice job on this one. I'm glad we got that. Do you want to try to find that? Okay. So we can think this out. You agree that you just found that this is the six. Half of it. It's half of 6. So if you're at 0, 0, then you have to add that 6 here. We don't rise or fall anything. We just say how many sets of square root of 3 comma. Not 9, that'd be all the way here. What's if you put the midpoint, boom, and you add the midpoint.
I think I added.
Yeah, like we can find the midpoint. Do you guys, you two, do you understand? Because I know you're using the calculator. It seems a little hard. Do you know how root 90 becomes 3 root 10? Just keep it root 90 for now. I'm good with that. I'm
Okay.
gonna or I'll show you one more thing. If you're here, if we have root 90, and Vincent, I'm sorry, I'll give it right back. Like I have no issue if you use that, or once you get this, if you hit this button, this one, there's this one.
Oh, okay.
Yep. You can just keep it root 90. Like this is awesome, and we will do this. It's easier than you think I imagine. I think I did the calculator one.
Yeah.
There's that, but it's so hard.
Okay. So
I'm gonna call it right now, just so you know. Senior year, you better win this.
yeah.
Oh,
Your
thank you.
hand's always so well set.
Now,
Okay, area. Let's find area.
is it easy?
I don't think that's
If you guys don't know how to find area, it might be worth checking to see if your book has a reference sheet in the back.
Don't we all?
That has
Correctly.
Like
Okay, like book.
So in this
That's-
class, we're not
It's just not
focused on it. Decimals.
Yes.
Just use decimals.
decimals.
Yep.
I think it's
Uh,
over here.
The better answer is if the radicals are the same. I don't know if it'll be in that one. It should
Yeah,
be in the
no.
geometry book. That's a writing notebook is the only reason.
Well, I think
Is there a book?
Why?
Because it gives like 3 root 10.
Can I show you how to fix it? Like, it's gonna be a decimal, and check it out. We'll just do an easy one. It must be 90 goes through 10. So everybody, I want you to see this, and I just showed this guys. But check it out. If we type square root of 90, and I hit enter, it's gonna give me 3 root 10. This button is this button. There it is. Okay.
So this is
Do you know how to find area of any shape? Do you remember? That's fine. Did we find perimeter? Did we find perimeter? Okay. Do you remember to find an area of any shape without a square or rectangle? No? Okay.
Oh, it is. Okay, I see. Yeah. So.
Base. Base. A equals 1/2 base height. What? Base height.
Is this a height? This is not a height.
That is definitely a height.
This is the height. So. Okay.
You guys are doing great. We're gonna sit down and do a little summary of what we worked on the boards. Yeah. I didn't stop this recording. It's gonna be so long.
Oh, really?
I don't know how. Okay, up on the boards, I gave you additional questions. What was my question? Area and perimeter. Put perimeter up top. What is the area of the perimeter? How do I find the perimeter of any shape? Yep. Add up all sides. So for a triangle, I'm gonna erase this down below. I'm gonna need some more room. Crossing for a triangle, perimeter is what? How many? Yeah, how many sides do we have in a triangle? Yes. So adding up all 3 sides. Okay, area. What is the formula for the area of a triangle? You all almost found it. Ashley, what was your group? You guys found it. 1/2 base times height. We found that. Or you can get it from a rectangle. What's the area of a rectangle? Yep, base times height. So this is my base, this is my height. If I divide this in half, I just made a triangle. And then this would be the area of that triangle, which would be 1/2 of the entire rectangle. Yeah? Okay. We're gonna actually keep going. We're gonna talk more about area tomorrow. But this whole unit, I didn't say triangles in the coordinate plane. I said polygons in a coordinate plane. So we're not just gonna talk about triangles. We're also gonna talk about some other shapes. Can you guys remember any shapes you guys had in the past? Trapezoid. Okay, you picked the hardest one, Carson, to do first. Trapezoid. What else? Keep going. Rectangles. I see we're keeping with quadrilaterals. Tell me some other quadrilaterals. So quadrilaterals, 4 sides. Square. Yep. Square. I hear parallelograms. I need more. Rhombus. Rhombus. I got one more. I'm gonna go outside and fly this when it's windy. Kite. Yep. And my kite. Okay. Tell me anything about any of these shapes. Lily, you first. Pick a shape. Tell me something about it. Okay, so we have two pairs of opposite sides are parallel and congruent. Thank you, Lily. Vincent, tell me something else about any of these shapes. Okay, yep, all four sides. Ashley, tell me something else about any of these shapes. Yep. So all four sides are congruent. Drew, what other shape also has all four sides are congruent? Yes, a rhombus. So all four sides congruent. Carson, any shape, anything.
Template has hair.
Yeah, and we're gonna end here today. Do you guys want to hear something funny? You guys have a different definition of a trapezoid than New York does. So, Carson, how many parallel sides? Exactly one pair. You have exactly one pair. New York, we have a different definition. So you have exactly one pair of parallel lines. We're going to continue with this and finish them up tomorrow. Okay.